Okay, so the title of the question is talking about a geometric series. So n equals 1, say to infinity. If it's geometric, then there's a starting value for the geometric series times r to the n minus 1. This is the general form of a geometric series. And if you're really, really unfamiliar with geometric series, look, this is a geometric series. That's all. Just multiplying by 2 in this case. This is geometric. Oops, sorry, dot, dot, dot. It's a geometric series if you're multiplying by some constant r for every next term in the series. Sorry, this is a geometric sequence, I should say, because it's just listing the numbers. The geometric series should be adding them all up. But the idea is the same. It's geometric if you're multiplying by some constant. We'll call it r. Oops, I want that. Okay. So this one is looking to be geometric because we have that to the power of n going on, but it's all scrambled up. We don't have just a clear r. We want to have just one power of n before we do anything else. So let me see what I can do. I think I gotta pause the video because this 1 minus n is tripping me up. Okay, so I have an idea. We want to just have one power of n, and it needs to be minus 1. So the first thing I can do is I can rearrange this. That's the same thing, right? This is the same thing as this, because if I factor out a negative sign, n becomes positive, which is what we want for a geometric series. And then I have my minus 1 because I had a positive 1, factor out a negative, now it has to be a negative 1. And I'm not sure what to do with this yet. Oh, it's e to the 6n. It's still summation. But this is now a negative, so I can kick that into the denominator. Oh, sorry, no, it's not negative anymore because I moved it to the denominator. And if I could just get this to be n minus 1, then I could combine them under one roof, because then I could raise the whole outside to the n minus 1 power. So if I just put the minus 1 in there, I can oh yeah, here we go. If I'm just multiplied by e, this is now the same as this term is, because e to the 6n minus 1 times e to the 1, the powers would add to make e to the 6n. Okay, and so I can just factor out that e, put it in front of the fraction, and now I have, oh, it's a 6n? Ooh, okay, so how about this? That's not going to work. How about e to the 6, and then this would be minus 6. Because then I could factor this a little bit more. That's e to the 6. Look, just to show you why I hesitated, I wasn't quite done because that would just get me e to the 6n minus 1. I'm trying to make everything have an n minus 1 power. So if I make this a 6, I can balance that by making this a 6 for the same reason. Then I can factor out a 6 from the top. I think I'm getting closer. What can I do? Oh, yeah, so that's it. Here, let's factor out the e to the 6, put it in front of the parentheses. This is going to be e to the 6 in here. This is going to be negative 3 to the n minus 1. And then this whole thing in parentheses is raised to the n minus, oh, no, that's gone. This whole thing is raised to the n minus 1 power. Because using the property of exponents, if everything's being raised to the n minus 1 power, then this could come and multiply to everything. That's what we want. That would turn back into what we started with. So that was a lot of weird looking algebra. But now we have an r. We have r was just some constant to the n minus 1 power. This is just some constant to the n minus 1 power. So all that work, we've got our geometric series. This is our a sub 1, this is our r, and this is our n minus 1. And why was that important? It's because if r is contained between negative 1 and positive 1, then you would say this series is going to converge. And the reason for that is because you're multiplying by numbers smaller than 1, so it's shrinking the number every time. So your series is converging because the numbers are getting smaller. If r was bigger than 1, like if r was 2, like in my first example, if r is 2, then this is doubling every time, and it's not going to converge. It's going to diverge because it keeps getting bigger and bigger, so the numbers you're adding are getting bigger and bigger. So we got to figure out if our r is between negative 1 and positive 1. Handy dandy calculator, raise that to the 6, divide that by negative 3. That's way bigger, or way out, it's a negative, so it's way smaller than negative 1. So we'd say this is a geometric series that diverges.